Hello everyone, welcome to lesson 5, not lesson 5, lesson 6, 8 is enough. By the end of this lesson, you should be able to answer the guiding question, how is the octet rule used in drawing Lewis structures and structural formulas? The do now was to finish the exit ticket. If you are absent, this will be excused. For this, you could use the whiteboard and or puzzle pieces or a scratch piece of paper to draw the Lewis structures and structural formulas for the compounds on pages 6 and 7 using the stuff we'd already gone over. You can do notes first, which we are here. Brain fart, we're going to keep going. So notes, the octet rule. Nonmetals combine so that each atom has a total of 8 valence electrons by sharing the electrons. The only exception, though that's always an exception, is hydrogen, which only needs 2 valence electrons in order to fill in the first shell. There are supposed to be 2 L's there. I think it is on yours. Boron as well is an exception that you might see if I'm feeling extra, or if we're talking about the shape of molecules, which we'll get into next week. But we don't see it a lot in class. It has 3 valence electron and they're all unpaired, but it's also small, so it only fills to pair up those 3 for a total of 6. So it does a reduced octet as well. There are expanded octets, but that is beyond the scope of this class. So if you're looking online and you're like, why is an oxygen sulfur forming 6 bonds, Miss Burt? It's an expanded octet. It's beyond the scope of this class. Don't worry about it. Cool? Are you laughing at me back there? Okay. So some examples. Previously, we looked at fluorine and saw that it has 7 valence electrons. When it pairs up with another fluorine, those electrons pair up. Right? And then drawing the structural formula, we change the bond to lines, but keep, and that's the key part, keep everything else the same. The octet rule is modeled in both the Lewis dot diagram and the structural formula. You can't just leave off the electrons in one or the other. All the electrons must be present and modeled or represented correctly. If we have water, which we did previously, but we'll look at it again, we pair them up. And we know that oxygen has 2 unpaired. Oops. And hydrogen has only 1, and we could do an open circle, so I don't have to switch pen colors to represent hydrogens. And this is showing our Lewis dot diagram. Then if we draw the structural formula, we change our bonds to lines, but make sure we keep everything else the same. Please, 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 please do not draw lone pair electrons on hydrogen. It's kind of like that weird like filler Lego that just kind of has like one little spot. It doesn't get extras. Okay? Kind of just plugs into the empty spaces and makes it all smooth. Okay, the honk 1, 2, 3, 4 rule and the octet rule both help you figure out the Lewis structures and structural formulas. Both of these rules can be satisfied using double and triple bonds appropriately as well. So we're going to look at some of those examples. Cool? So carbon has how many valence electrons? 4. So 1, 2, 3, 4. And I'm going to switch pen colors because we got 3 elements here. Hydrogen has how many unpaired electrons? 1. It only has 1, right? So we'll fill in with hydrogen here. And then, ooh, we're getting fancy. 3 pen colors. Ready? Nitrogen has how many valence electrons? 5. So 2. Thank you. 3, 4, and then we compare the 5th one here, right? Like fit it in where you can start pairing it. That makes sense? But we have 2 that are unpaired for nitrogen. Do we have any others that are unpaired? 2 from carbon. So I'm going to move my nitrogen ones in and get them ready to pair. And I'm going to do the same, but switch my pen color for carbon and pair them up. What type of bond is that? Triple bond, because there's 3 pairs being shared right there. So hydrogen, when we draw the structural formula, has 1 bond to carbon. And then carbon and nitrogen have how many? 3. So 1, 2, 3. And then nitrogen has a pair that is not shared. Can you guess which ones I like the most? No, I mean Lewis dot diagrams or structures, or the dot structures or the structural formulas. Because it's very clean and I can see all those bonds. Okay, you need to practice both first, and then after lesson 6 you get to pick pretty much, unless I explicitly ask for one or the other, and that'll be on assessments. Okay. So next is nitrogen, right? Nitrogen we said has 5. Right? And so we're going to pair our other nitrogen up. So there's 1, 2, 3, 4, 5. We're going to share a pair for both. So there's 1 pair. And then share our other pair. Who's planning to use the whiteboards now? If the pens are dead, chuck them in the trash. New pens are in the drawers. Then if we draw it, we change our bonds to lines, and then our lone pair electrons honestly can go anywhere, and I like to draw them on the sides because it makes it look very clean. But could you draw them on the tops? Could you draw them on the bottoms? Could you draw them on different sides? Yes. They just need to be paired and on the correct atom. And then carbon dioxide we did in lesson 5. But once again, well, I guess I should do 4. Carbon has 4 valence electrons. Oxygen has 1, 2, 3, 4, 5, 6. And we will repeat that on the other side. 1, 2, 3, 4, 5, 6. And then oxygen needs to share another pair, so it'll take 1 from carbon and share. Oxygen needs to share on the left another pair, so it'll share another pair with carbon. So I pull 1 unpaired electron in from each one and pair them up to form a bond. Okay? So the friend lists are no longer lonely. They have a friend. And we take our bonds and represent them as what in the structural formula? Lines. And we got double bonds between both. So now at the bottom of page 5, not 2, 5, please answer the guiding question in 2 to 3 sentences. Thank you for tuning in.